Hello, algebra students, and welcome to our lesson summary video on our lesson for writing and graphing systems of linear equations. This is the first lesson for our unit on systems of equations, and in this lesson, we talked about how you can create a system of equations to represent a situation. That's also going to include what a system is. And then we're going to talk about, in this particular lesson, how you can solve a system of equations by graphing and what it means to be a solution to a system of equations. This conversation about solving systems of equations is a conversation that's going to be ongoing. There are multiple methods you can use to help you solve these systems. And so the focus today is going to be on graphing. So you've got a lot of graphs in your future. To get us started with the first part of our goal for this lesson, which was about what a system is, what they look like, and how you can write a system, we're going to be talking through this problem here. So starting us off, a costume designer needs some silver and gold thread for the costumes for a school play. She needs a total of 240 yards. At a store that sells thread by the yard, silver thread costs 4 cents a yard and gold thread costs 7 cents a yard. The designer has $15 to spend on the thread. Whew, we've got a lot of information there right off the bat, and I'm going to go ahead and start highlighting some of the key information. First of all, they are talking about how much yards she's trying to buy. So I'm going to go ahead and highlight she wants a total of 240 yards there, and that's between two types of things. There's the silver thread and the gold thread. And then they also mention prices. So I know that silver thread cost 4 cents a yard. And then we're also told that gold thread costs 7 cents a yard. And we know how much total money she has to spend. So as we're looking at all of that information, you can break it down into two types of information. Some of that information is related to the cost of all the stuff she's trying to get. And then the other information is related to the amount of the materials, the amount of thread she wants to buy. So to start us off and to help us with our conversation in this video, I'm going to have you pause the video in a moment and you're going to answer these two questions here. Both of them are about writing equations based on the information that was given to us. Writing an equation is a skill that we spent a lot of time working on in the last unit. So hopefully that looks familiar enough. I encourage you to pause the video now and try to come up with those two equations. All right. So as I was highlighting, I was trying to keep it color coordinated so that I highlighted anything related to cost in yellow. So we've got silver thread costs 4 cents a yard and gold thread costs 7 cents a yard. If I use X to represent how much silver thread she buys and Y to represent how much gold thread she buys, we're going to end up with an equation that looks something like this. That's 4 cents for every yard of silver thread. And then we've got the 7 cents for every yard of gold thread. And she can spend a total of $15. And I might include off to the side as well that X is, wow, that's big. That X is going to represent how many yards of silver thread she buys, and Y will be real similar, how many yards of gold thread she buys. So we've got that first equation. Notice I'm pulling out all the numbers that had to do with money because that equation is representing the cost. Now they gave us more information than that though. They also mention how much thread she's trying to buy. We're told she wants to purchase a total of 240 yards. Well, that total, I can go ahead and I know that's going to be here. That total yards is coming from two things. It's coming from silver thread and gold thread. I've already defined my variables here. X is the yards she purchases for silver thread. Y is how many yards she purchases of gold thread. So we're saying between these two, she wants to purchase 240 yards. If I add the yards of silver plus the yards of gold, it's going to add up to 240 yards. If we pause here and look at what we've got, we've just created two equations from the same situation. Each of those equations are related to one constraint in the situation. Now, that word constraint is something we learned back in the last unit. Constraint, remember, are just the limitations put on the problem or the story. So here there's two limitations. There's a limitation with cost, right? She's got $15 she's going to be using to purchase things. And there's a limitation on how many yards she's getting. She needs 240 yards, so we can't get more or less than that. From this problem here, when we create two equations to represent two constraints from the same situation, this right here is what systems of equations come from. So we've got down here, this situation involves two quantities and two constraints, length and cost. Two or more equations that represents the constraints in the same situation form a system of equations. So as we go through this unit on systems, our stories we're going to be looking at are going to be similar to these, where there are not one, but two equations we can generate from that information. Now, I had them written out separately here, but usually, and you can read down here, it says a curly bracket is used to indicate it's a system. Lots of times when we write a system, we use this bracket right here just to show that they're together because they're coming from the same problem. That bracket is not necessary, obviously. In your homework form, you're not going to be able to type that bracket. But for a lot of our problems we're going to look at in this unit, you're going to see that bracket there. That bracket's just saying, heads up, this is a system. So this first part and the first part of our lesson we did together was focusing on this idea of what is a system, what does it look like, and it comes back to this idea there's going to be two equations representing the two constraints. That definition mentions you could have two or more equations. In our unit, we're just going to be working with two equations, but if you move up into higher math classes, you might be working with situations that have three or four equations. So you have that to look forward to. I'm going to jump us down to the next part. If you remember from our goals from earlier, we talked about knowing what a system looks like and being able to create and write our own systems. And then the rest of our conversation from this lesson has to do with solving systems or these problems where you have two equations at once. So we're continuing on with this costume designer. We're told the costume designer wants to figure out how many yards of thread she can buy to meet both of her constraints for cost and the number of yards needed. So what we've got right here is a graph that represents all of that information from earlier. To start us off, I actually want to go ahead and have you match up the two equations we wrote from earlier with these two lines. So if you recall from earlier, those two equations we wrote were these two right here, and I can copy them down from above. One of them was x plus y equals 240, and then there was this second one. Let me confirm I've got those numbers matched up correctly. Yes, I do. So go ahead, pause the video right here and match up each of these equations. One of them is going to go with the blue line and one of them is going to go with the black line. Go ahead and do that now. All right. So because both of these equations are in standard form, I would probably match them up based on x and y intercepts. So the x and y intercept of this line both happen to be 240, which means it's going to go with that black line there, which means, of course, this other one here is going to be our blue line. And so I've got them in those boxes to help us remember which one goes to which. So we've got this graph here representing those two equations in our system from earlier about the costume designer. And I've got a couple questions for you to consider. You can consider them just using the information from earlier or using this graph. My first two questions are these. The first one is, could she purchase 160 yards of silver thread and 80 yards of gold thread? And like many things in this class, be prepared to explain why or why not. And then same exact question, but with different numbers. Could she purchase 200 yards of silver thread and 100 yards of gold thread? Explain why or why not. As you're considering that question, I'm going to zoom out just a little bit and come up just a little bit so you can see the equations, the graph. And just like the others, please pause this video and see if you could work out, would those be okay combinations of thread for her to purchase? Go ahead and try that now. Okay. So as we said, you can answer this question using any of the information we've got. We've got a story problem from earlier. We've got this beautiful system of equations now, and we also have this graph. I want to start off by thinking about it with the graph, actually. So if we look at 160 yards of silver thread and 80 yards of gold thread on our graph, where would that point be that represents this information? Well, 160 yards of silver thread. I'm going to go to 120 on my silver thread or my x-axis, and then up to that 80 yards of gold thread. So silver thread, 120, and then if I go, I'm 160, and then if I go up to 80, we notice it's at this point right here. It's a point on my black line. What does that mean? That goes back to some of the work we did in our last unit. Well, if that point is on the black line, it means it's a solution for this equation represented by that black line, which this equation came from that idea that she needs a total of 240 yards. So if I look at these numbers, if she purchases 160 yards of silver and 80 yards of gold, yeah, that does equal 240 yards. So she would be getting the exact amount of material that she needed. It's not on this other line, though, which had to do with the cost. So if we think about what this would look like for our cost, if you do those calculations, 160 yards times our 4 cents a yard, 80 yards times our 7 cents a yard, you're going to see that it's not equal to $15. It's actually under $15. So it is okay for the total amount of yards needed, but it doesn't cost $15. So I'm going to argue she can't buy that. She can't buy that because it's equal to the amount of yards she needs, but it doesn't match up with that cost constraint we had. There was one other question here that was about the 200 yards of silver and the 100 yards of gold. Similarly to what we did before, if I go and look at 200 yards of silver thread and 100 yards of gold thread, that takes us to this point right here. This time, if we do the math with that combination of numbers, I notice it's on that blue line, which matches up to our cost constraint. That combination of silver and gold thread would meet that $15. We could even do the math. If you take 200 yards of silver times it's 4 cents a yard, and you take your 100 yards of gold thread times your 7 cents a yard, that 200 yards times 4 cents a yard is going to work out to be $8. 100 yards at 7 cents a yard is going to be $7, and that does equal 15. So it would equal the $15 she has to spend. The problem is that doesn't add up to 240 yards. We said earlier she needs 240 yards of thread. And if you look at those numbers, you could do that math in your head. That's not going to equal 240. That's going to equal 300 yards. So similar to earlier, but the opposite, we see that it meets the cost constraint, which is good. We want it to equal $15, but doesn't equal 240 yards. We see that it's actually more than 240 yards because 200 plus 100 is 300 yards. So if we're thinking about this costume designer and what she can purchase, we saw these were just examples. One of them met the $15 constraint, but not the 240 yards of thread constraint. And the other one was the opposite. It was 240 yards of thread, but it wasn't $15. So when we think about this question, how many yards of silver and gold thread should she buy so that she's meeting both of those constraints? If I look at the graph and I look at the system of equations, what's this magical combination of the amount of silver and the amount of gold thread she should purchase so that it equals 240 yards and also equals $15? Well, using what we know about points on these lines, we had said earlier, if the point is on the line, it means it's a solution to that constraint. If we're on a hunt for which combination is going to be a solution for both of these, it's going to look like, based on this graph, a point that's on both lines. And as if we look at our graph here, there's only one point that shows up on both lines, and you might have already guessed it. It's this one right here. It's going to be that point where those lines intersect. That point 60, 180 is on our black line and on our blue line. So when we consider that question, how many yards of silver and gold thread should she buy to meet both constraints of the situation? And how does that graph help us find the solution? The graph helps us find the solution when we look at the intersection point. That's going to be the key for when you talk about solving systems by graphing, is we graph both of the lines so we can find that intersection point, because that is that magical point, that magical combination of numbers that meets both of these constraints. So for this answer, how many yards of silver and gold thread should she buy? She needs to buy 60 yards of silver and 180 yards of gold. I'm getting those two numbers from our graph right here. 60 yards of silver and 180 yards of gold thread. Now there's one last question to this. And that last question is, how could you confirm 60, 180 is the solution to both equations? Well, it's similar to what we were doing earlier up here, where we did the math. You can substitute that pair of numbers into both of your equations. So we've got the equations over here. X plus y equals 240. That's representing that length constraint. So if I take x plus y equals 240 and substitute 60 and 180 into that equation, I see that it works out. It's a solution to that equation, or we say it satisfies the equation. I could do the same thing with our cost constraint. So this equation from earlier represents that cost constraint. 0.04x plus 0.07y equals 15. If I substitute my pair of numbers into this equation, 180 equals 15. This first part here would be 2.4. And then this other one here, my goodness, is going to be 12.6. And that does, in fact, equal 15. That 2.4 is just going to represent you're spending $2.40 on the silver and then $12.60 on that gold thread. So we can confirm that a point is a solution point using substitution. That's going to be the key if you're trying to check and see if something is a solution point if you don't have a graph, right? If I have the graph, I can just find that point on our graph. So to summarize what we're seeing here, the point 60, 180 is the point we call our solution point. The solution point for a system of equations is going to be a pair of values, so there's two numbers there, that make all of the equations from that system true. I'm seeing it makes this equation true because 60 plus 180 does equal 240, and it's also making this other equation here true, which represents that cost. It does add up to be $15. Graphing the equations is one way you can find a solution to the system of equations. I had mentioned at the beginning of this video that there are going to be multiple methods you can use to find a solution point for a system. Graphing is just one of our 3 ways we're going to be looking at in this unit. So the last part of this video is a great way for you to check and see if you understand the math we learned in this lesson. It's a little practice problem for you all. So I'm going to come down here. Here are the graphs that represent this system. So here's our system of equations, and here are the graphs of those two lines from that system. Using this information here, you can use that system of equations or the graph. There are 3 questions here for you to answer. Number 1 says which point or points are solutions to the equation x plus y equals 4. Number 2 says which are solutions to 5x plus 10y equals 25. And then that last question, which are the solutions for our system of equations? Go ahead, pause the video now, because you trying this math is going to be the best way for you to see where you're at, and then come back when you have answers for 1, 2, and 3. All right, I hope you tried this. When we're looking at this, it's all going to be about where the points are on the graph. So when we're looking for solution points for this first equation, x plus y equals 4, that's going to be that black line on our line. We've learned in previous lessons that solution points for a single equation are any point that lies on the line. So as I look at that black line, point E and point C are both on that black line for x plus y equals 4. So E and C would both be solution points for that single equation. And you could always confirm with substitution. So for example, E is the coordinate pair 2, 2. And if you substitute 2, 2 into this equation, 2 plus 2 equals 4, that's true. Any other point on the graph that's not on that line wouldn't give you a true equation, like 2 plus 2 equals 4. We could do something similar for number 2. So number 2 is looking for solutions for that blue equation, that blue line. Well, that's going to be point D and point C. Similar to what we had said above, if you wanted to confirm that, you could substitute that pair of numbers into this equation. I will say, looking at point D, it's in the middle of that box, so it's really hard for me to know exactly what the pair of numbers is that represents that point. It's going to be somewhere between 1 and 1.25, but I would have to guess. I don't even know. C, though, is easier to substitute. It's 3 and 1. And so if we were to do that, 5 times 3 plus 10 times 1 does, in fact, equal 25. We get 15 plus 10, which is 25. Now, that last question, and that's really the new part for today, is what solutions do we have for this system here? We had said the reason this graph is so great is because to find the solution to the system, we're looking for what point is a solution for both equations. That's going to match up on our graph with which point is on both lines. That's going to be our intersection point here. There's only one solution for the system of equations, and that is the point C. We already saw right here that C is a solution for that second equation because 5 times 3 plus 10 times 1 equals 25. If I substituted that pair of numbers into our first equation, which was x plus y equals 4, we're going to have 3 plus 1 equals 4, which is also true. It was true for both of those equations, so therefore C is that only solution for the system. We're going to continue talking about systems and their graphs in tomorrow's lesson as well, and look at a lot more situations that could be represented by systems of equations, because systems are new, right? It's going to be a whole different type of story problem or word problem that we're looking at that lets us know we could represent it with a system. So that will be the focus tomorrow, but hopefully you're leaving this video feeling confident about how you can write a system of equations and how you can use a graph to find those solutions. Thanks for watching. Have a great rest of your day. Bye.